Hello YouTube, Never-Ending Student here, and it is finally time to take care of the State of the Bench or Electronic Workbench update video. I had meant to take care of this at tail end of 2024. That didn't go through. Lots of iterative changes kept going through, but I'm finally at a stable point and we can make the video. So, let's start over here. And sorry, there's going to be some intermittent shaky cam stuff. I will try to be sparing with that as I can. We'll start over here, just briefly, not getting too far into it. This is my primary low voltage tool bag. When I'm in the field, this is with me, and when I'm at home, this is where it sits. All the hand tools supplement what I have that I leave in the bench and on the bench, and I use those in combination with the main bench. All right. Before we get to the primary instrumentation stack, let's briefly touch on the bench overall. Sorry, yep. So I guess we'll back up again. So, the bench itself, for the table, we have a 5-foot by 30-inch table, and in the back there, we'll take you over there. A little hack I've done to give me a little bit more space is the table, as you can see there, it isn't actually touching the back wall. There's maybe 5 or 6 inches clearance, and I did that kind of to make the table have more depth to it, or at least more usable space, because that space back there, it's not so far of an overhang that anything's going to fall through. It's fine for passing cords through, and it gives me that much more space as usable working surface, since it would kind of be wasted if it was pushed all the way back. So it used to be pushed all the way back. I learned from that and realized it didn't have to be, so now I have a little bit more real estate to actually work with. Okay, so that's the main table. We have lighting, lots of lighting. There's the LED lights, there's the basically giant LED shop light that provides a lot. I cover this in the infrastructure video. You can basically never have too many different types of light from different angles. When you're working on electronics or just anything for the workbench, lots of light with lots of different options just comes in handy. Power. I'm also going to be pretty brief on this. We have power strip there, power strip there. There is a power strip under there, which I'll give you a look at. It's a pretty long power strip. Now, that's limited to 0.5 amp per outlet. So I can't put any large power consumers like my soldering stuff on there, but we have that. Then down here we have another power strip. So lots and lots of power. It's one of those things that you can just never have enough of. Moving on from that, so we've covered the actual infrastructure, we've covered the tool bag. Alright, now we can go to the primary instrument stack. Let's scoot this in, get you closer. So we have here my daily driver oscilloscope, the Rigol DHO914. In terms of specs, certainly not the most capable oscilloscope out there. We've had better spec'd oscilloscopes for many decades, but I love this little thing. It has so many modern features, including HDMI out, running on USB-C power, and it's Android based, and there's like a multi-hundred page EEVBlog thread dedicated to hacking this thing and getting tons of options out of it, including getting more frequency. I think up to 250 or a little bit beyond, so 250 meg. Really, really nice modern scope. After that, we'll start with this. So we have a couple of Pine Power, or Pine 64, Pine Power USB power supplies. There's the one there, and then that little square back there is another that I have strapped to the pegboard backing, since USB power is a common need here. Right now, it's feeding power to the armature lights, like those and the one on the other side, and it is providing power to the Rigol. Below that, well, while we're on the subject of light, I'm trying not to skip around too much, but we also have the majority of the LED strips are powered by the common 12-volt rail. There's the 12-volt power supply, and there's the 12-volt rail for the majority of the LEDs. Alright, so the primary instrumentation stack. What you see here is what I use for 80 to 90% of everything I do when I'm using instrumentation. So we have here my kind of pride and joy multimeter, the Keysight 34465A. I found a guy a while back, not too long ago. He was selling some 34465As, the white model, on eBay for 700 bucks. It looked really beat up, but I noticed he was nearby me. I did a little bit of OSINT. I was able to find an email address for the guy, and the blind, I kind of sent out an email. Hey, I noticed you on eBay. I'm like half an hour drive away from you. If I go out there, test it on site, and either decide, yes, I'll buy it, you're not going to get a return, or no, I'll walk away. So no eBay fees, no packaging, no shipping, and just cash on the barrel. What's the best price you'll give me? I didn't know he had one of the black models at the time. He had two, actually, and I kind of waffled back and forth on wanting to get the second one as well, but I let it go. $500 for the 65A. Super happy with that. Below, we have my first 34401A. It is still either the most accurate or tied for the most accurate 34401A that has passed through this lab. And it's one of the oldest. But it kind of makes sense. You know, the voltage references, the older they get, the more stable they get. And this has been very, very stable. So I've been keeping that. Next up, we have a new addition. This is the Advantest R6144. It is a precision programmable voltage and current source. It is so precise once warmed up that a lot of people consider these to be essentially secondary cal sources. Right now you can see it's at its primary range, or top of the range at 16 volts. For any source, you're going to get the most accurate output if you're at the top of its output range, as that is generally going to be where the calibration takes place and where its one of its aligned sources is, so to speak. So you can see I have it at 16.000, and that's beautiful. There's no null or math offset right now. 16.0000 volts. That's just beautiful to me. And if we go into the trend chart, auto scale, you can see the ripple noise on that. So up here we have 16.0001 and 15.9999, which is, at this scale, the smallest it can get. So we have ripple noise of, I would estimate, so we're talking 1 millivolt there, or sorry, 100 microvolt. So this is probably on the scale of 20 to 50, yeah, call it positive and negative. Call it plus minus around 35-ish microvolt. Actually, we can probably ask. Let's go to math. Statistics. Oh, this is showing, yeah, it's not going to give us good statistics because this is since it warmed up, and I was changing it, so I'd have to clear the readings and let it accumulate again. Don't worry about it. All right, so let's go back to display. There. And we can have math go away. Pause. Okay. Sorry, I had to figure out how to get math off the screen. And because one should not be afraid to admit when they can't figure something out, I couldn't figure it out. I had to turn the darn thing off and back on. So that's something for me to look into later. So yeah, super accurate voltage and current source from between 1 millivolt, between 1 microvolt output, although you have to control for noise floor if you want to get that low, and 32 volts, and between 1 microvolt and 160, or sorry, between 1 microamp and 160 milliamps. Truly excellent source for testing meters and, you know, demonstrating their accuracy. Before we go a little further on that, on the top of the accuracy, right there we have the recent acquisition, Keithley 2001 7.5 digit meter. That is up for repair. It was basically input abused and had some blown components. But I'm super excited to get that repaired and add a 7.5 digit meter to the bench. Below that, we have my primary bench power supply. It is the GW Instek, or Goodwill Instek GPD 3303S. 2 channels of 30 volt 3 amp and 1 channel of fixed 2.5, 3.3, or 5 volts. For the vast majority of power needs in electronics, I mean, that's going to do what you need 90+% of the time, and it does. It is also surprisingly precise and accurate for a typical bench power supply, like impressively so. Certainly, this is orders of magnitude better when it comes to getting that last digit and stability and linearity. But yeah, I love that little power supply. What next? It may seem like a little thing, but this clock. This is a very common use item. It tells, like when I'm making a documentation video, it shows the time, the date, And importantly, for issues of demonstrating accuracy, it shows at the time that I'm testing an instrument what the temperature in Celsius and the humidity is, which, you know, is relevant. Next over, there we go, that's fine. We have soldering. So, my primary iron is the AiXun T420D. It is a 2-channel, I think either 200 or 200 plus watt iron, and it uses JBC compatible cartridges, which I love. That is absolutely the way things are going, is to have a modern non-JBC system that will use JBC cartridges, because I don't want to pay like $3,000 to $5,000 for a soldering iron setup, but I am willing to pay $25 to $35 for a cartridge, given that JBC is still the reigning king for soldering iron cartridges and quality control on those. So yeah, that is the way to go of the current cutting edge. Getting a non-JBC system that is tested and verified good, and using their cartridges. Actually, before we go the rest of the way on soldering, the EEVBlog 121 GW meter. I found this a while back on eBay and absolutely would not pass up. So that lives on the bench. Okay, continuing with soldering. We have the Hakko FM204 desoldering station. That is the one that has the vacuum pump built into it. And then I have the FM 2024 handpiece. Now, something to mention with these, and we'll go ahead and zoom back out, is that both of those items have power switches in the back. Why? I don't want to give my equipment a reach around if I want to turn it on. I want a straightforward button or switch in the front. So what I did to get around that is I got a rack mount power delivery unit. So those are already switched on, but they're not getting power, and my switches are down here. And while we're on soldering, I have my fume extractor with a lot of sound suppression buried in that corner. It still has a route for air to get out the outlet. But I have my switch for the Hakko fume extractor here. And then the AiXun soldering station is number 2, and the Hakko desoldering station is number 3. Now, while we are on the topic of soldering, let's back this up just a little bit. The OmniFixo. That is a part of the bench. It is a wonderful tool. I've covered this in a separate video. The hands down best third hand or helping hand tool for soldering ever yet designed. I'm really looking forward to if someone comes along and designs something better, but this is phenomenal. And that is the M4.4 version. All right. Next up. So, in the center back, we have the lab computer. So in my desktop and on my field laptop, I run Linux Mint. It's what I'm comfortable with and what got me into Linux in the first place. The lab computer currently runs MX Linux, although for certain purposes that I'll bring to or come to in a second, I am considering switching over to a more Security-oriented Linux distro like Kali is one of the better known ones, but there's also Kitsurugi, or there's a few others that are oriented towards that. There we have the 4-channel KVM. So right now I just have the lab computer and the Rigol connected, and you can see there's some numbering or labeling there. And I also have my microscope and the computer umbilical on it. And I'll show you that in a sec. Oh, and on the topic of soldering, we kind of skipped past this. Q-tips and general cleaning supplies. When soldering using flux, common, cheap, general cleaning supplies are definitely part of the electronics bench. Screen there is a 27-inch Dell monitor on an armature, and then behind there is just some cable routing, and I already showed you the power strip. Next up, we have some instruments that are not part of the primary stack. These are seldom use, but nice to have. There is the Hioki 3540 Milliohm tester. It is a dedicated 4-wire resistance meter, and it goes down to the 30 milliohm range. It is quite accurate for low ohms, and when I need to measure something that's below 1 ohm, or like below 100 milliohms, it's very handy to have. Over here we have the Agilent LCR meter. That is the model 4263 Bravo. Lucky pickup at an industrial auction. Very happy to have gotten that. I think I got it for like $190. You typically see them on eBay for like $1,000 to $1,500, so yay. And this is what sparked the latest redo of the bench. I've had this microscope for a while, but I only recently got this wonderful armature. I love this thing. So, the microscope is an Amcope Trinocular 45X. And then the camera is the RisingCam RT5109. It's kind of one of their flagship models for a 4K 60 FPS camera. And I have been very, very happy with that camera. There have been some bumps. I had like a cold join solder issue that became an issue about half a year in. RisingCam support was pretty good. They had me go through some repair attempts, which I had volunteered saying, hey, this is my setup, I'm willing to try. And in the end, we weren't successful with the repair, but it was definitely worth a try. They sent me a replacement mainboard. I popped that in, and I'm back in business. Down here we have the iFix's IL37. It is a polarizing ring light. If you have a microscope, get a polarizing light source. It is night and day difference, and you can get these for like $30 or less on AliExpress. Really, really good. Oh, for a while they were the only game in town in terms of polarizing ring lights. I did recently pick up this. Mechanic now makes one, so I'm gonna take a look at this and give a little compare later. Alright. A note on these armatures. I paid like $200 for it. And that was on sale with AliExpress coupons and such. Normally it can cost $300 or more. And if you're not discriminating about hunting down good prices, it can be a lot more. You don't have to break the bank to get this kind of capability. Even knowing about the alternatives, I still like this because it goes over the entire bench. And I like that it was purpose-built for this and has a lot of adjustment. But you should know that you can use computer, or sorry, yeah, TV and computer screen Visa mount armatures. 3D printing has given us an adapter. You can get on eBay for like 20 bucks. That takes any number of different microscope mounts, including this interface right here, and converts it to a 75 millimeter square Visa adapter. So instead of spending $200 to $400 on one of these armatures, you can instead spend between $40 and $60 on a very good quality screen armature and get the same functionality. Now, maybe it won't reach out a meter from, the mount point, but if you would like to spend 1/8 the price for the whole thing, or 1/6, and still get this kind of capability, look into that. It's literally any arm mount that you want for a monitor, and what you want to search for the 3D printed part is microscope Visa adapter. That's VESA. Go to eBay, and there are 3D printed models. They show you basically the CAD model, and you can order it. Or, of course, given the times we're in now, if you have a 3D printer, you can make it. So that's the majority for the first layer of the bench. There is an 8-port gigabit switch back there, just a standard Netgear dumb switch. Let's move on to one moment. Okay, I was about to move on to the upper shelf, but we do have a little bit more for the first layer. So, in a previous video, I discussed how my standard armature magnifying glass light had failed. I had a rectifier failure in the little wall wart power adapter, so I cut that off, and this just runs on 12 volt DC, and I already have that 12 volt rail. So I wired it in, routed it along there on the opposite side, and back in business. Other than that, there we go. Small hand tools for the bench. We have mostly a variety of tweezers. So everything from ceramic headed tweezers for both thermal insulation and non-conductance. So I can manipulate stuff like if I'm in a situation where I need to solder on an active board, and that doesn't come up so often, but sometimes, then you don't want to short things out while you're doing SMD work. So, ceramic heads for your tweezers. Kind of a niche item, but occasionally very useful. Then we have the Hakko brand CHP needlepoint tweezers. And for a while, these were my standard for like really sharp end tweezers. But then I got into microsurgery tools. And yeah, super sharp. They have a little guide there, and it is just really fine needle tip, and they're quite good for where the tolerance is on coming together at the tip. Sometimes you need to grab something really tiny. These are more the same, although we also have tiny little scissors. Also useful when you're doing SMD repair or board repair and you have the extremely fine gauge wire. At that point, you're no longer at the area where you're using like side cutters to cut that. Microsurgery scissors, definitely the way to go. Dental picks. Dental picks used off of eBay are, as long as you take your time and look for deals to get them cheap and in bundles or bulk. Very useful for electronics work. Sometimes you have to pry and prod and poke. Cleaning tools. Cleaning is definitely part of electronics. Sometimes we get things in that have been industrial environments and need detail cleaning. And then we have various spudgers and plastic pry bars for either non-marring or non-conductance. And of course, you know, small needle nose and such. And then cleaning for the bench. Basically, I just sweep dust and stuff into my trash bin. We also have El Cheapo caliper, specifically with plastic jaws. Now, why do I have this when I also have this nice Mitutoyo? So, I have this, why did I keep that around? Well, two scenarios. One, if I want to mic something that is abrasive, very niche situation, but if it's like a tungsten file or something that might scratch up and mar the surfaces on my micrometer, I don't want to do that to the Mitutoyo. But the main use case is measuring a magnet. I don't want to magnetize my caliper, and plastic jaws are the correct tool for that then. Alright, so that's the small tools that we keep here. And yes, now we can go to the instrument shelf. So let's back up a little bit, and oh, no, I guess we're not quite done with small tools. I'm only going to touch on this briefly. Tajima, very good Japanese tool brand. I love this tape measure. It auto holds, you don't have to lock it or anything, and it won't get pushed back. And then dual inch and metric. Love this thing. And then various precision screwdrivers, Klein, Wera small precision set, various cuts, and more screwdrivers and torque stuff. Over here, we just have a little closable magnet. It's just an Altoids tin with a couple of disc magnets and tape over it, and that is for storing screws, so that they can't be accessed by asshole over here. Hey, jerk. Who's super pretty. Yeah, you are. Who thinks he can get away with stealing screws when I'm unscrewing a multimeter. You do. He gets away with too much stuff because he's so pretty. Alright. And yes, he loves getting on the bench and stealing tiny screws. Jackass. Alright. So, main instrument shelf. Over here, let's get a little closer. We have a couple of Kikusui electronic loads. Kikusui is an excellent Japanese brand. These are PLZ 334Ws. Each are rated for 330 watts. Range is 150 volt and 66 amp. Oh, we didn't touch on this during soldering. The Quick 861 DW hot air station. It is my first hot air station, and it served me very well. I might change my mind sometime in the future, but I don't see myself replacing that anytime soon. Power. We have a couple of Agilent power supplies. For situations when I need more than my main bench supply will give me, I have the 6614 Charlie. That goes up to 100 volts. just half an amp, so you know it's only 50 watts. And then right here, this was another really lucky auction find because these go for stupid bucks on eBay. The Agilent November 5745A, 1U rack mount, 30 volt, 25 amp, 750 watt. So this is mostly for the amps it'll give me. If I need to work on or test a blower motor from my van, for instance, which I have had to do, vehicle stuff that runs on 12 volts, a lot of that will want a lot of current. The blower motor I had, it wanted like 17 amps. So this was a must, specifically when diagnosing that. And then the power over here and the electronic loads are all routed around from behind to this banana jack rail for convenience. Next up, sorry for the knocking around, we have some new stuff. We'll get the old stuff first. So over here I have my first original signal generator. It's just a ON 10 megahertz AG 1012, 2-channel, nothing special. It was pretty cheap on eBay, and it was my first, recently it was my first signal generator. Out of like high school, I had a basic electronics bench set of a power supply, oscilloscope, signal generator, and bench meter, like super old. I don't even remember the brand. It was all like blue powder-coated steel. I permanently loaned those out to a friend back when I wasn't really doing electronics a whole lot. But yeah, still have that. That's useful for low frequencies because it's, you know, 10 megahertz and all the way down. Then we have my main oscilloscope for when I want more frequency or just, you know, an analog scope. The Tektronix TDS 744A, 4-channel, 500 meg, 2 gigasample. Now, new stuff, because I'm just getting into RF. We have the Rohde and Schwarz SMIQ 02 Echo. That is a 300 kilohertz to 2.2 gig SIGGEN, and it has an immense amount of features and options compared to that, which is just, okay, you can choose a sine wave, a square wave, a sawtooth, or a pulse, and then noise. This much more comprehensive in the options, and I am happy to add that to the bench. Over here, we have the Anritsu MS2623A, 9 kilohertz to 6.5 gigahertz spectrum analyzer, and another thing I'm quite happy to get. Both of these were kind of lucky finds on eBay. An electronics test equipment rental company was cycling out equipment that they weren't using much anymore, and these were in excellent repair and functionality. They were selling them as parts, and as such I got them very, very inexpensively compared to what they usually go for. But I, you know, sent them a message asking for the history of the devices, and they said, yeah, they're all working, they just haven't been used in a couple of years, so we're cycling them out as unused inventory. So that was really cool. Let's see, what else? Some storage. This is new since the last bench update. Some common tape. I find myself needing certain types of tape often enough that I didn't want to open up a drawer, and I wanted them as first order accessibility. Not all of it needs to be out here perhaps, but I have the space, so why not? El Cheapo duct tape. This is actually a cleaning material. The like Gorilla brand duct tape is what I use as actual duct tape. This I peel off and I use to clean surfaces as one of my cleaning options. We have polyamide tape or Captain tape, standard Scotch magic tape, packing tape, self-sealing silicone, double-sided foam tape. I use that quite a lot for bench organization. Thinner, double-sided foam. And then we have gecko tape. That's the kind of nano grippy tape. It doesn't actually use adhesive. It uses like gecko foot replicated stuff. Standard electrical tape and PTFE. You can never have enough lights. And then back there, oh yeah, we didn't really touch on the umbilical from the KVM. So this is my computer umbilical. It's a set of 10-foot cords of, standard computer power, USB, HDMI and DisplayPort, and then Ethernet. And that's for when I'm working on computers. I buy a lot of stuff at auctions for resale, and computers are in my experience, so I go through a fair amount of computers, servicing and cleaning and reselling them. Now, something we missed when we were going over the first level, so let's quick go back here. I'll give you a close-up. So right here, we have a couple of Ethernet switches, and not switches like we usually mean switches, but switches as in literally a physical A or B switch. And we just have some Ethernet coming out of that. So what's going on there? Well, what that is something I set up after I had a rather unusual experience with an industrial computer that I had plugged in. It was out of some factory, and it had some industrial controls software that I'd never seen before. It was really interesting looking. And then I was connecting it to do Windows Update, because I decided, I won't wipe this yet. I want to poke around. And it went online, and my best guess is that it did a license check. Decided, oh, I'm not authorized to exist anymore, and it nuked itself. I had a moment of like, you're taking my agency away from me, man. I own you. Maybe I don't own the software or the license, but screw that. I bought the computer. I want to play around with it. Don't make choices for yourself. It offends me when computers make choices for themselves that I would not make. So, I set up a separate internal sandbox network. The default is on the home network, but I can switch over either one or both of those for either just the umbilical or the umbilical and the lab computer. And then they will be on this Asus ROG gaming router over here, which gives me a lot of control options and allows me to set up a sandbox network. So it can't access the outside world, but I can still get network access or selectively controlled network access to that computer. And it also allows me to, put the lab computer on there. And that's why I was talking about I'm considering switching from MX Linux to Kali to kind of use that as a way to interact with and interrogate computers. All right, so one moment. All right, so aside from that tape holder on the upper rack, we do also have that battery charger right there. It's just an i4 IntelliCharger for my 18650s. I just have the power cord for it hanging off here. I can, plug it in, use it when I need. That's secured by 3M double-sided tape. And then up here, we have my normal little Adam Savage style phone mount. I'm not sure if he's the original person that ever thought of this. He might well be, or he might have gotten it from someone else, but super useful idea. It gives you a lot of versatility for where to put your phone, and then the phone holder that normally screws into this quarter 20 mount is what's holding the phone right now on the tripod. Alright, so that's it for the main bench. Yeah, we have the right side. So, back here, we have a lot of inventory that's either pending testing, pending sale, or not yet processed, but up for processing like cleaning. Like right there is one of the 34401As that I haven't done cleaning on yet, and that's up for cleaning. Although the next project is definitely the Keithley. Other stuff that is of interest, I have my precision resistor standards up here. I have 4 of them. Like this one is, they're all old Soviet models. This one is a 1960 10 milliohm standard. And I just leave the Kelvin leads on this one. But I saw those. Those were actually on sale by an eBay seller out of Ukraine. So I was quite happy not just to get those for a reasonable price, but also to be sending some money to Ukraine. Slava Ukraini. Over here, we have probe storage and leads. As we grow out an electronics bench, we need more and more probes and leads. So this is the common use stuff. Most of the stuff that I use day to day for banana jacks, oscilloscope leads, Kelvin clips, and various adapter cables, as well as some USB. And then most of the rest of them are one of those drawers. I have a lot of additional leads and cables down there. Now, I'm gonna shrink down for a bit. We also have, we're gonna take you off the mount. Sorry, this video is going long because there's a lot of stuff. Voltage references and standards. Recent eBay pickups. That's the analogic 3100. I believe AN 3100 voltage standard. That's functional. It's very, very slightly off, but not in any way that's, broken. It just needs a little calibration. This one is the Fluke 341A DC voltage calibrator. Happy to have that. It is non-functional, so that's up for repair. It probably is going to be a repair after the Keithley. And then we're getting towards the last of it. This is some new storage. I'm not really going to go through the tool chest storage because I've done that, at least some of it, in a different video. But we have some new stuff in here that's kind of exciting. Alright. So, you may have seen this before. The DMM Check Plus. This is a really nice little all-in-one general reference source. So you have 5.0000 volts out, 1 milliamp. You can have either AC or DC. You have a set of precision resistors, inductors, and capacitors. It's $200 and change. It is really handy to have. Next up, before I got the high-end RF stuff on the bench, this was one of the first things I got for getting into RF, the Tiny SA Ultra Plus. This is the 407 model, and I believe this is still the latest one. It goes up to 7.3 gigahertz. It's been really fun playing around with this. Here we have the Hack RF with the H4M version Portapack. It is similar in concept to the Flipper, but while the Flipper does like GPIO and infrared and USB and a bunch of other miscellaneous stuff, the Hack RF is much more specific to, well, RF, and it has much greater depth of capability in radio frequency compared to the Flipper. I also got into software-defined radio, and I have a RTL SDR at my computer right now. Those are really wonderful little devices. You can pick them up for like 40 bucks or less on Amazon. Definitely recommend. Although, I don't necessarily recommend giving Amazon your money, but if you can find them somewhere else, then yeah. I've been wanting this capability on the bench for a while, and I'm glad I kind of waited on it, because only recently did XGeku come out with the T76. This is a chip programmer. It is probably, right now, the best chip programmer out there, at least in terms of kilodollars. It has compatibility with an immense amount of chips, and it has a huge number of adapters, so you don't need a chip that fits in there. You can use all sorts of different form factors with the various adapters that are out. New one connects by USB-C instead of micro USB, and has an adapter out for various additional adapters beyond what just fits on here. So what that's useful for, oh, and if you want to look this up on YouTube, look for the T56, because that's been out for a long time and there are a lot of videos about it. There's only one guy I know of on YouTube at the moment that has a 76, and that is Matt Brown. He's less a electronics specific guy and more IoT hacking guy. He has really good content, so I would definitely recommend taking a look at his channel. That is, again, Matt Brown for IoT hacking, or Internet of Things hacking. Beyond that, in here is just more adapters for the Geku. We have some replacement screens for the Agilent 34461A through 34465A. I have a 61A that needs a replacement screen. It's working. It just has a line through it, and these are like, I don't know, $8? Really cheap. Various RF SMA connectors, and various different antennas in there. Finersi FNB58. This is a USB multimeter. More than that, really. It does protocol decoding. It can force like different voltage states by telling whatever is sending it power that, hey, I'm a 20 volt compatible, I'm a 15 volt compatible, I'm a 9 volt compatible, etc. And it will give you, of course, the regular multimeter stuff, where it says, you have this much voltage, current, power. It'll log power consumption. Really handy device. So much stuff we use these days is USB, and a USB specific multimeter is more and more relevant. And geez, I'm closing on an hour. I'm sorry. Down here we have various RF connectors and adapters. This is one of those like $10 ultra tiny little preheater plates. Useful for just really small SMD work if you need some preheating. Cleaning supplies. Sometimes Q-tips are just too big, so we have various different kinds of smaller little cotton and foam cleaning Q-tip variants. Foam polymer erasers, also for cleaning. Sometimes getting like embedded grime in plastic out, this works really well. Try it. My soldering supplies are in there. The actual solder, super wick, tip tinner and such. I moved them from off the bench just to in there. And then miscellaneous storage down here. Some fuses, the boxes for the tiny SA and such. And then some other projects, like I have a dash cam that's pending for installation. Okay, that's everything. I think I finally got through the full take without flubbing. So yeah, that is the state of the bench. And if you're still with me after very nearly an hour, I do apologize for not being able to be faster about this, and thank you for watching.